Physics, okay, Physics 0625, Cambridge IGCSE, revision notes for topic 8 and half of topic 5.4 and topic 3. So we will start off by defining work. What is work? Work is the amount of energy that is transferred when force is applied on parallel distance. So it is the amount of energy transferred only when you apply a force to an object or to anything on parallel distance. Work is a scalar quantity. If a force is applied to an object but does not result in movement, then no work is done. So if you apply a force to an object but there is no movement on the object, then there's no work done. The SI unit of work is joule. This means that the amount of work done is equal to the amount of energy transferred, because both are measured in joules. So change in energy is equal to change in work, which is what we're gonna come to right now. The formula of work, we have two formulas of work. Work is equal to change in energy. Work is equal to delta E, and work by its own formula or by the definition is equal to force times parallel distance. According to the triangle here, the formula triangle, we have force is equal to work times distance. Work is equal to force divided by distance, and distance is equal to force divided by work. Now, since force is in Newton and distance is in meter, another equivalent unit of work is 1 joule, which is equal to 1 Newton meter. So 1 joule is equal to 1 Newton meter. This means that the work has two units, joule and Newton meter, but energy is only measured in joule. So even though work and energy are the same, the units are not the same. The units for energy is only joule, the unit for work is joule and Newton meter. Now, what does work depend on? Work depends on two factors, force and the distance moved in the direction of the force. Work is directly proportional to the force applied, because the greater the force, the more work is done, the more magnitude is created. The distance moved in the direction of the force is also directly proportional. The more you push an object, the farther it goes. This means you have applied more work. You have put more force to make it go farther away, which means more work has been executed. Now, what happens when work is done? Two things happen, or let's say two main things happen. The object is moved over a parallel distance, of course, because when you do work, you're applying force in a parallel distance, and when force is applied in the direction of motion. Work is done in Newton meter. The amount of work that is done in Newton meter is equal to the amount of energy transferred in joule, because like we said before, the energy in joule is equal to the amount of work done in Newton meter, because both are SI units of work, but both are not SI units of energy. Work and energy transfer. So whenever mechanical work is done, energy is transferred mechanically from one store to another. There are some key facts to consider here. The first one is if work changes the speed of the object, okay, then there's a change in kinetic energy, because kinetic energy is the energy of motion of particles. So this means the work is equal to change in kinetic energy. If work changes the object's height, okay, this means that there's a change in GPE, gravitational potential energy. So this means work is equal to change in GPE. If the force acts in the direction object is moving, the object will gain energy to its kinetic energy store. If force acts in opposite direction to the object is moving, object will lose energy to its surrounding as heat. Alright, I hope that's clear. So now we can move on to some examples of work. The first one, a ball is lifted to a height. Energy is transferred mechanically from its kinetic energy store to its GPE store. Another example, a bird is flying through air. Energy is transferred from the bird's kinetic energy store to its thermal store, and some is dissipated to the surroundings as thermal energy. A quick note is that air resistance or drag does work against the bird as it flies. So air resistance or drag is going in the opposite direction of the bird's motion, as it is the frictional force in in fluids, which are gases and liquids. Here's a physical example using diagrams, a free body diagram. Okay, so we have an object in the middle. This object, what are the forces acting on this object? Okay, let's say this object is a car and it's moving forward. Okay, So of course the first thing that's going to be acting is the gravitational force, which is the weight acting downwards. Then we have the reaction force in contact, or the contact force, which is preventing the object from falling down, fighting the gravitational force, which is going upward. Then for the object to move forward, we have a thrust force forward, and we have a frictional force backward, which is going to be our drag. If the thrust is greater than the drag, then the overall distance is going to be in the right direction. So T, which is thrust, is doing useful work, D is doing wasted work, and W and R, which is weight and reaction or contact force, are doing no work. Power. Power is the rate at which a force can do work, or the rate at which energy is transferred. So basically, how fast energy is transferred is power. Okay, how fast can you transfer this energy? Okay, like for example, when you plug in a switch to connect your refrigerator, how fast is the energy transferred, or the electricity transferred to the fridge? Okay, that's going to be a measure of your power. So power is a scalar quantity because it has magnitude but no direction. The SI unit of power is watts. Okay, the watt is the unit of power when 1 joule of work is done per unit time. So 1 watt is equal to 1 joule per second. Joule per second means rate of energy transferred or rate of work done. Since power is, by definition, it's the rate at which a force can do work. But because work is also the amount of energy transferred, so we have two formulas for power. The first one is power is equal to work divided by time, rate at which work is done. The second one is change in energy divided by time. Because since energy transferred and work are both the same thing, so they both have the same formula triangles, just replace the first value with work and energy change. Now what does power depend on? Power depends on two main factors: the work and the time, directly proportional to the time, of course, to the work. If you have more power, it means you're performing more work in a shorter amount of time. So the greater the work, the more power. The time is inversely proportional. The most power is executed when the most amount of work is done in the least amount of time. This means the rate of power is fast. So the lesser the time, the more the power. Highest power is equal to most amount of energy transferred or work done in the least amount of time. Power and efficiency. There are two types of power when it comes to calculating efficiency. We have useful power and wasteful power. Useful power is useful energy divided by time. So P is equal to useful energy divided by time. Wasteful power is wasteful energy divided by time. Efficiency. Efficiency is the ratio of useful power energy output from a system to the total power energy input. So basically output over input, but useful output over total input. Efficiency of a system measures amount of wasted energy and energy transfer. If a system has high energy efficiency, most energy transferred is useful. If it has low efficiency, most energy transferred is wasted. So basically you divide when you input energy into a system, there's always a wasted and a useful. To find the efficiency, you take the total amount of energy you inputted, put it in the denominator. You take the useful output, put it in the numerator. Divide, that's your efficiency. To simplify the formula of efficiency is useful power, work, or energy divided by inputted power, work, or energy. And inputted is equal to useful plus wasted. Lastly, we're going to talk about pressure. Pressure is the concentration of a force per unit area. In simple terms, pressure is the force executed per unit area, or force divided by area. Pressure is scalar quantity because it has magnitude and no direction. The SI unit of pressure is Pascal. 1 Pascal is equal to 1 Newton per meter squared, but 1 Pascal is not equal to 1 Newton per centimeter cube. Okay, so if it is given in newtons per centimeter cube, do not put Pascal, keep it in Newton per centimeter cube. If the question is given in Newton per meter cube squared, you can put it in Pascal. Of course, by the definition, the formula is very simple. Pressure is equal to force divided by perpendicular area. Okay. Sorry, there's a mistake here. This should be pressure. Okay, pressure is equal to Pascal, pressure is equal to force over perpendicular area. The area should always be perpendicular cross-sectional area of the object where the force acts right angles 90 degrees to it. Okay? Of course, by the formula, we can tell that pressure depends on two main things, force and area. Force is directly proportional. The more force you apply, of course, the more pressure. You can just go next to a wall, just try pushing on the wall. The more force you're going to be applying, the more pressure you're going to feel. Area acted upon, inversely proportional. If the force is over a large area, there is more, the pressure can evenly spread along a large area, so there's small pressure. If the force is over a small area, like as if a needle is pinching you, you're going to feel a lot of pain because the force is all concentrated at one single point. Pressure in fluids, again, fluids are gases and liquids. So we're not going to go in depth in this, just revising some few facts here. Pressure in liquids, when an object is immersed in liquid, the pressure is acting, as you can see in the diagram on your right hand side. Okay, the pressure is acting in the center of the object at 90-degree angles from each side. Okay. The formula to calculate pressure in liquids is simple, rho gh. Rho means the density of the fluid, times g, the gravitational field, which is 10 Newton in our syllabus, times the height or depth. Okay. But using this formula, of course, pressure depends on three things: density, gravitational field, and height. All are directly proportional. Greater the density, greater gravitational field, greater the height or depth, greater the pressure.